Hi everyone. Today's lesson is on transformations. We're going to be starting to talk about the 4 different types of transformations. And a transformation is a change in the position of a figure. You might have heard of the word transformation in your everyday life, right? There's a movie about Transformers. On social media, maybe you might post a Transformation Tuesday picture. But in math, we're talking about the change in the position of a figure. So I'm going to take a triangle and I'm going to move it somewhere else. Or I will take a trapezoid and move it somewhere else on the coordinate plane. So there are 4 types of transformations. There's a translation, a reflection, a rotation, and a dilation. The first 3 we're going to focus on this week. And then the last one, dilation, is actually in Module 2, which we will get to in the following week. For today's video, we're going to focus on the first transformation, which is called a translation. A translation is a transformation in which a figure slides but does not turn. Every point of the figure moves the same distance in the same direction. And I'm just going to write the word translation. One way to help you remember is right here. A translation is when you slide a figure. And I remember because translation has an SL, just like the word slide. And imagine a triangle, and I'm going to slide it somewhere else. Did it get bigger? No. If I take a triangle and I slide it to the right and then I slide it down, did it get bigger? No. Did it get smaller? Definitely not. Think about if you slide across the dance floor. Did you get bigger or smaller? No, you didn't. So a translation creates 2 congruent figures. You're going to want to write this down. This is a very important vocabulary word. The word congruent means the same size and the same shape. So take a look at these 2 triangles, green and red. They are congruent. They are the same size and the same shape. And the symbol we use to show congruent is an equal sign with like a little wave above it. These 2 triangles, the blue and the green, they are not congruent. Although they are both triangles, they're both the same shape, they are not the same size. Where have we seen congruent and non-congruent shapes? Well, we see them all over. You get a can of soda when you go to the store. They're all the same shape. So all of these cans are the same shape, and these particular cans in the picture are also the same size. So these cans would be considered congruent. However, now when you go to ShopRite, you could buy the regular soda cans, or now they sell the minis. They are the same shape, but they are not the same size. So these soda cans would not be congruent. So another thing you want to pay attention to besides the word congruent is the word pre-image and image. So if you look at this triangle ABC, I'm going to slide it to the right, and then I'm going to slide it down. I go to the right and then down. But just by taking a glance, how do I know I didn't go up and then left? You need to be able to decipher which triangle came first. The triangle that came first is called the pre-image. And we've labeled the angles A, B, and C. When I take a pre-image and I move it somewhere else, whether I translate it, rotate it, reflect it, I create a new image, which we just call image. But the way to tell the difference is this A came first, and it's just labeled A. But the new location of point A, we show by writing an A with an apostrophe. This A with an apostrophe means this is the new location, and we say A prime. The new B location is B prime, and C is C prime. That's how you read it out loud. So we know this image came first, this triangle. That's the pre-image. I slid it to the right and then down, and now I have my new image, which we just call the image, but we know that it's the second one because of the apostrophe, the prime symbols. We're going to do some examples of translation. So here I've just taken my regular Snapchat picture and I slide it over to the right and maybe even down a little bit. Did my picture get bigger? No. Did my picture get smaller? No. So it's the same size, same shape. Therefore, these two pictures are congruent. Here's our first example. It says, describe the translation. I have two squares on my coordinate plane, A, B, C, D. Which one was there first? Well, this triangle in quadrant 4, this square in quadrant 4 does not have the apostrophes next to the letters. So this one was there first, which means this one with the prime symbols came second. So now you want to describe the translation. How did I move from square number 1 to get it all the way up here to square number 2? Okay, well, just like a coordinate, when we describe translations, we're going to describe the movement on the x-axis first. And then we're going to look at the y-axis. The x-axis moves left and right, the horizontal x-axis. When I move left, is that positive or negative? Negative. Think of the number line. These numbers over here are negative. And when I move to the right, positive. These numbers over here are positive. So pick any point you want on this first square. Let's start with point A. I want to go and move from point A to A prime. How many spaces do I move to the left or to the right? Well, I'm going to go to the left. 1, 2, 3, 4. I go to the left 4 times. Once I'm here now, I have to keep going to get up. I'm going to now move up. How many? 1, 2, 3, 4, 5, 6. So then I went up 6. That is my y value, because y, I'm going to just do this, is either up or down, the y-axis. When I move up, is that positive or negative? Positive. Up here, all these numbers are positive. And when I move down, my numbers are negative down here. Now, let's just double check. I'm just going to erase our work. I want to make sure that I counted correctly and I'm on the right track. So let's pick a different color and let's pick B just to make sure. You know what? Let's pick C. Did I still move left 4 up 6? Okay, let's count from C to C prime. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I did it. Left 4 and up 6. Now, sometimes you're going to see the translation described like this. But in algebra, we write it algebraically. So you're going to take your original coordinates, and what are you going to do to them? What did we do to the x? We went left 4. Is left positive or negative? Negative 4. And then what did we do to the y? We went up 6. And up is in the positive direction. So this is how we would write the rule for the translation. Left is negative and up is positive. And that is how to describe the translation. Example 2. Translate the triangle 4 units right and 3 units down. What are the coordinates of the image? So here's my first pre-image. Notice again, there's no apostrophes. So I'm just going to rewrite it over here. I go 4 to the right, or right 4, and 3 down. So you're going to take each point, J, K, and L, and go right 4 and 3 down. Let's do J. 1, 2, 3, 4 to the right, 1, 2, 3 down. This is my new J. How do I label it? J prime. Let me erase my little track marks. Let's do the same for K. 4 to the right, 1, 2, 3, 4, down 3, 1, 2, 3. Here's my K prime, new K. And then L. 4 to the right, 1, 2, 3, 4. Now down, 1, 2, 3. This is L prime. Now let's connect the dots, make our triangle. This is figure number 2. Make sure you have your prime symbols for sure labeled. That's how you tell the difference between triangle 1 and triangle 2, which one came first. And notice, look at the two triangles. Are they the same size? Yes. Are they the same shape? Yes. They are congruent figures. Let's say by accident you made a mistake and your L stretches all the way over here. So here's your new triangle. Do these two figures now look congruent? No. A translation creates two congruent figures. So if your second triangle looks a little crazy, you might have done something wrong and you're going to want to go back and check your work. Okay? And you can also double check because you know the length of this is 1, 2, 3. So the length of the new one is also going to be 3 units. So this is L prime. Two congruent new figures. And the last one. This one looks crazy. It's an upside down T. That's okay. Don't stress. It has a little bit more coordinates, but it's nothing we can't work with. The game piece or image A, B, C, D, E, F, G, H is drawn on the coordinate plane as shown. The figure will be translated 3 units to the right and 3 units up. So let's do this. 3 to the right and 3 up. When I go to the right, is that positive or negative? Positive. So it's x plus 3. And when I go up, is that positive or negative? Positive. Y plus 3. Oh, I just realized we did not do that on the last one. Let's go back. The rule, to the right 4. Right is positive and down is negative. So it would be x plus 4 and y minus 3 because you're going down on the y-axis. So we're going to take all of these points and go up 3 or right 3 and then up 3. So let's start with A. And don't forget to label the A prime. Up 3, right, or right 3, up 3. So 1, 2, 3, 1, 2, 3. Here's my new A prime. Let me erase my little marks. B. Right 3, 1, 2, 3. Up 3, 1, 2, 3. B prime. Let's do H over here. 1, 2, 3, 1, 2, 3. Here's H prime. Now, you can start to connect and see that AH here is 3 units, which means the new A prime and H prime also has to be 3 units. Then I went up for B, 1 unit, which means G prime is going to be 1 unit up as well. Now, when you do yours, you're going to have bigger graph paper. So I'm sorry it's so smushed, but yours will not be. Then C, if I move right 3, up 3, 1, 2, 3, 1, 2, 3. Here's my new C prime. I'm going to take my black. Now, can you fill in the rest of the figure? Well, here would be F prime. And then C to D is up 1, 2, 3. 1, 2, 3. Here's my new D prime, which means E prime is right here. Okay, so that's a little crazy, but that's all right. F prime. So it says write the coordinates for each vertex. So now we're going to find the coordinates of A prime, B prime, C prime, D prime, E prime, F, G, and H. Coordinates of A prime are located at 4, 4. B prime is up here, which is 4, 5. C prime is 5, 5. D prime is up here, is 5, 8. E prime is here, which is 6, 8. F prime is 6, 5. G prime is 7, 5. And H prime is 7, 4. Sometimes the questions will then ask you to write the coordinates, so you just want to pay attention and make sure they're labeled. Are my two shapes congruent? Same size, same shape. Yes? And all we did was slide it to the right and up. We didn't turn it, we didn't flip it, we didn't make it bigger. So that is a translation.